Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Sweeping Seas by GDC, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, column, and designated 9-cell region contains the digits 1 through 9 once each. Excuse me. We have even island Nurikabi, where all odd digits 1, 3, 5, 7, 9 must be orthogonally connected with each other. So that means you can get from any odd digit to any other odd digit in this grid just by going through edges, all while staying within the odd digits. So say, for example, this was a 6 and a 4 here. Then this would not satisfy the Nurikabi because this 3 is an odd digit, but you can't orthogonally connect to the rest of the odd digits in the grid just by going through edges while staying within the odd digits. So that's an example of how even island or Nurikabi works. Also, each 2x2 group of cells must contain one even digit. So you could not have something like, say, 3, 9, 5, and 7 because this 2x2 area does not contain an even digit, which is 2, 4, 6, or 8. And that's how even island Nurikabi works. We also have odd sweeper circles, where a digit in a circle is odd and counts the number of odd digits up to 9 in the up to 9, counts the number of odd digits in the up to 9 surrounding cells, including itself. So for example, any circle counts the number of odd digits that are in the 9 surrounding cells centered on that cell. So say we had 6, well, it can't be. A digit in the circle is odd. So say we had these cells were odd. That would mean this has to be 7 because this would count the number of odd cells in the 3x3 area that is centered on the cell it's in. And it has to be odd, and it counts the number of odd digits in the surrounding cells. And that's how odd sweeper circles work. And finally, we have island size squares, where a digit in a square is even. So all the squares are even. And they count the number of cells in its island. And the cell's island is the orthogonally connected group of even cells, including itself. So say this was essentially the island group here, and the rest of these were odd. That would mean this would have to be a 4, because it counts the size of the island that it's connected to. It's orthogonally connected to. And again, orthogonally connected just means that you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within that region. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so all of these cells are even. All the circles are odd. The 9 is odd, the 3 is odd. Okay, so a circle in the middle of a box is always going to always count 5 odd digits because you'll always have 5 odd digits in a box, and this box is centered around the 5 digits there. So this has to be 5. In addition, this circle in the corner, you cannot have so the odds sorry, I can't speak right now. The odd digits in the surrounding squares can only be up to 4. And obviously this is even, so that would be 1 or 3 here, because must be an odd digit. But if it's 1, that means these are both even, and then this circle cannot orthogonally connect to the rest of the odd cells. So this cannot be 1, it must be 3. And therefore, we'll celebrate because it's 3 in the corner, but these two are odd. This is 5 again for the reasoning that we have here. Because in a box, you have 5 odd digits, 1, 3, 5, 7, and 9. Okay, this is next to 3, at least. It cannot be 9 because this is even. It could be 5 or 7 here. So this is 5 or 7. This has to be an even digit, and so that means it's at least 2. So that must go that way. These cannot be on the same island, because if they were, they would be the same digit, and you'd have a repeat in the column. Same with these two, so this must be odd, and this must be odd. Same with this must be odd also. Hmm. Counts number of cells. Okay. This has missing 1 and 2, so this could be 5, 1, 3. It cannot be 1. It can never be 1 in a circle, because that would mean that its surrounding cells are all even, and then it can't orthogonally connect to the rest of its odd digits. So this can't be 5. It could be 3, 7, technically, and 9. Actually, it cannot be 9. If it were 9, the problem is that in these cells there would be 6 odd digits, which is not possible, right? So this is 3 or 7. Okay. So this has to be 2, 4, 6, or 8. 2, 4, 6, 8. 2, 4, 6, 8. Same here, 2, 4, 6, 8. So this has to either go this way or this way. We don't know which. This will go this way or that way, or both. Obviously, it could be both. So there are at most 2 odd digits here. You could have 3 even digits here, though. Okay. So this must go odd here or odd here. We're not sure which. It could be odd in both, technically. Interesting. Each 2 by 2 group of cells must contain at least 1 even digit, so this must be even. Okay. Because this 2 by 2 area has 3 odd digits. Obviously, okay, so then this has to connect. Well, it doesn't have to. It could technically be a separate island. It probably connects, though. Okay. Each 2 by 2 area. Okay. Obviously, one of these is even, at least. Can you ever have 7? No. If you had 7 here, that would be... Can you ever have 7 in that surrounds a circle with the Nurikabe rules, where every 2x2 region must contain at least one even digit. Well, this has already 2. And one of these is even. So this cannot be 7 digits here. So this must be 5. I'm wondering if 7 can ever be in a circle. You only have 2 even digits if it's 7. So I think the answer to that is no, right? So say you had 3 here. Say you had 7 here. You can only have 2 evens in the surrounding 9 cells, but then this is a 2x2 area that has all odds, and this is a 2x2 area that has all odds. So this cannot be 7. This is 3, not 6. This is 3, which makes this not 3 or 7, so it's 5. So for 3, that means both of these have to be odd. And we have 3 evens here. We have 1, 2 odds. We have another odd, and these are all even, which means the remaining digits in the row are all odd. Since this is a 2x2 area that has 3 odds, this must be even. This is at least 4, so this can't be 2. We have 5 odds here. These are even, even, even. One of these is even, and then the remaining 2 are odd. This 2x2 area has 3 odds, so this is even. Same with this 2x2 area, so this is even. Let's see. This has to connect to the odds here. Wait, that doesn't work. Huh. That's a little problematic. Why doesn't it work? Huh. That is problematic. Huh. Because then it cannot orthogonally connect to all the odd digits. Hmm. I think the logic behind the 7 not being possible is valid. But the problem is that this doesn't make any sense then. We have 3. The problem is these are both odd. And then this has to connect. Well, no, because it can't get out. These are all even. These are all even, right? Because you have 3 cells there. That makes these odd. And this doesn't orthogonally connect. Can Can it be 7? It just doesn't make any sense to be 7, though. This has to be 5. What am I missing here? Am I missing something? Oh, you can have 7. Okay, so this can't be 3. You can have 7, and the way you have 7 is this. You have to have 2 evens here. Okay, so this has to be 7, so that's what I'm missing. So this can't be 7, and it has to be this shape. Because otherwise, it just doesn't work. So you cannot have 3 here because of the Nurikabe rules. But you can have 7 because, as long as it goes this way. You can't have in the corners because the problem is the 2x2 areas, but you can have them disrupting this way. So that works that way. Interesting. Okay. That means we have 5 odd digits in column 2. So therefore this must be even, all there. We have 4 evens in box 1, so this must be odd. These could be part of the same island. So this is at least 5, so it can't be 2 or 4 here. Two. Can this be 3? Maybe? I don't know. Okay. We need... Okay, so this is going to connect to 2 other digits that are even, guaranteed. Right? Because there are 4 in this box, and they're both connected some way. So 1, 2, 3, 4, 5, 6, 7. This has to be 8. And it has to connect to here. Then to form 8. So this is even. This has to be 8. And it connects to the other one, so this is not connected to another even digit. So that's odd. So we have 1, 2, 3, 4, 5, 6, 7. We have an 8th somewhere here. We don't know where. Let's see. So this cannot be 8 here. No 8 here. This has to be at least 2. Could be more. What could it be, though? So this is 2, 4, 6. Oops. 2, 4, 6. This connects to... Could be 1, 2, 3, 4... 5, 6. So I think it's at most 6 here. So this is 2, 4, or 6. Can it ever be 8? I don't think so. You can't have more than 4 in row 9. And then it cannot go up here. So this would always have to go 4 that way, then here, and that's 4 already in box 8. So no, it's 2, 4, and 6 going that way. Um. Hmm. Hmm. 3 or 5. Hmm. Can this ever be 3? If you have 3 going that way, or 3 going something like that, maybe. Hmm. It could connect this way for this 3. One of these two is even. One of these two is even. At least. Could be both. Only one at most is even here. Hmm. That means we are guaranteed. So only one is even at most here. That means we are guaranteed 3 out of these 4 are at least are even. Hmm. Okay. Um. Hmm. What else do we have? Maybe I'm just not good with Nurikabe, but I'm sort of struggling with uh this puzzle. Eight can't be here. 8 can't be here or here, so 8 has to be here. Okay. This is 2, 4, or 6 here. That means 8 has to be in row 6, one of these two. Hmm. Um, hmm. Yeah, I'm kind of struggling with this a little bit. Anyways, this could be red as long as it connects. Can this ever be blue? No. If this is blue, that forces this to be red, and then this red doesn't orthogonally connect to the rest of the red. So this is guaranteed to be red here. Hmm. So this either connects that way or it connects this way. Huh. If it connects this way, okay, so we know there's at least one, there's one even and one odd here. We're not sure which is which. Hmm. Hmm. Um. Hmm. This is obviously 2, 4, or 6. Where's the 3 in column 2? Cannot be here because 3 in the column, or the box, and this is filled out. So this must be 3 here. That leaves these as 1, 5, or 7. Cannot be 5 because of 5 in the column. This is 1, 5, 7, though, so that's valid. This is cannot be 3, 5, or 7, so it's 1, 9. This could be 1, 3, or 9 here. This can't be 3 or 5, so this is 1, 7, or 9 here. This has to be a 1-9 pair here, which means in box 1, what is the remaining odd digit? It has to be 7. So this is 7, which eliminates 7 here, so that's 1. This can no longer be 1. This can no longer be 1. It's 3 or 9. This has to be 5, 7, or 9. This has to be 1, 3, 5, or 9. Oh, this can't be 5 because of 5 in the row. This is then 1, 3, 7, or 9. Obviously, if this is 3, then this has to be 3 here. Maybe I have to think of the logic of this island here. I don't know. I don't think I would consider this easy. This doesn't seem easy per se. But maybe I'm just not good with Nurikabe logic. It's fairly similar to Yin Yang, but not quite the same. Because the thing is, the blue islands can be a lot of them, right, by themselves. Okay. So what happens if this is 3? That means only one of these could be... You can only have 4 evens here. One of these would then have... One of these is guaranteed to be odd, at least, because we have 3 evens in that column. So could you be odd, odd, odd? Maybe. And then connect that way? Yeah. What you can't have is even, is odd here and then even, even. Well, no, you could. You could have that. Because it could connect that way, right? Um... You could connect that way. That is valid. This cannot connect this way. Oh. Does that tell us anything? I'm not really sure. If we try to do something like this, the problem is then we don't have enough evens in row 7, so these would all be odd, which would force all of these to be even, and then the 3 would not orthogonally connect to the rest of the odd digits. So one of these is at least even. That means we have one odd here somewhere. Hmm. Okay. Hmm. Um. Hmm. um. Hmm. This is kind of annoying. Oh, this cannot connect this way. Can it ever get to 6? I think the answer to that is no, right? Maybe it could connect that way. And then connect. Oh. So how would it get to 6? It would have to. It can connect here, but then that's 5 at most. Um. So it can't connect to there if that's 6. If we tried connecting that way, the problem is it can't go. It could go here. Okay, that does work. Hmm. So it could be 6. Uh, I don't know why. I'm not. This is not. This is not translating well to my mind. Hmm. Okay. So if this connects this way, that's interesting. So if it connects this way, that means it has to be at least 4, but it can't go any more down because we have 4 evens then in column 4. So that means it would have to extend that way, no matter what. Otherwise, this can't go this way, and then it extends that way. So this always goes that way then. Interesting. So that's guaranteed. Hmm. Again, you could not do both evens here. If you do both evens here, this is all odd, so that forces this to be even. This cannot orthogonally connect to the rest of the odd digits. So one of these is guaranteed to be odd. Maybe both. Hmm. Can this be even? I think the answer to that is no. If this is even, this has to go out somewhere to connect to the odds, right? So then it has to go this way. It cannot go the full 5 here because we know one of these is odd. So then it has to connect that way. But then these 5 odds would force all of these to be even. So then it could not connect this way. So this must be odd here. That's interesting. One of these at least is even. Hmm. So you cannot connect all of these being odd. So it must either connect this way, which is 5, or it could connect this way. It can't connect that way, though. It could connect to here, and then this connects that way. That's possible. Uh, hmm. This must be at least 4. It cannot be just 2, right? Because we have already all of these odd digits. So if it's just 2, what would that be? It would be here, here. These would be odd, odd, and this would be even, even, and that would be greater than 2. If we tried here, here, you have odd, odd, but that would be even. That's at least 3. If we tried here, here, these would be odd again, and this would be even, so that would be at least 3. So this is at least 4, 6, or 8. Hmm. This is 2, 4, or 6. This is hurting my brain. I don't know why. Hmm. Uh, uh, um, hmm. Cannot be 3 or 7. We have 1, 5, and 9. I don't know why, but this is just really hard for me right now. Okay. This has to connect out this way, because otherwise it won't be connected. Oh, maybe I should make the odds blue, but I'm not used to that. Okay, well, let's make these green. We'll have a sea of blood here. Um, yeah, maybe that's another thing that we need to do. That's interesting. So if this is red, this has to be green here. But can this connect? And that would be 1, 2, 3, 4, 5, 6 reds in box 2. So no. So this has to be green. Okay, so that's part of... Okay, so then this is at least 4. Um... Hmm. So one of these at least has to be red. Because we already have 3 greens in the row. Hmm. If this were red, this would have to be green. Or it doesn't have to be. It could be red, red. So say we had this as green. That forces this to be red, which means it would have to connect that way, but then this wouldn't be size 4 island. So this cannot be green. This is indeed red. So it could be red, red. It could be green. If it's red, red, this has to be green, and this must connect out this way as red. If this is green, it still must connect out this way as red. So that's red. Okay, so then this is 4 at most. So this is 4, which means this cannot be 4. One of these is green, the other one has to be red, which means we have 5 reds in box 2. So this must be green here. This could potentially connect out that way. We don't know. One of these again is green, one of these is red. This is 2, 6, or 8. Oh, we have all 4 even digits in column 4. So this must be odd. It's part of the C. That means this is 2 or 6. This must be then a 2, because it only connects 2 digits here. We have 5 odds in row 8, which eliminates odds in the rest of the row. So these are both even. This has to connect to an odd cell. So this is odd, odd, odd. That's 5 odds in box 9. So this must be even, even. One of these is odd, one of these is even. Therefore, this must be even, even here. So that makes this odd. So this is 4. This cannot be 4, so it has to be greater than 4. So it must connect out this way. And it must connect there. So it's at least 6. These cannot be 2. This can't be 2. Where is a 2 in box 8? It has to be here. So this is a 6-8 pair. This cannot be 2. That forces this to be a 2-4 pair, which eliminates 2 and 4 in the rest of the row. So this is 6. This is 8. This can't be 6. This 2 eliminates 2 here. This is a 6-8 pair here. This is 2 greens here. Okay. This is all connected. One of these is red, one of these is green. This must connect to 5. It must have 5 odds in the surrounding cells because it cannot be 3. So this is red, which makes this green. So this is 5 or 7. This cannot be more than 2, because if it tried to go here, that would be 3, and then we had 4 even digits in box 5. So this must be 2, which makes this 6. So no 6 here, no 6 here. This is a 2-4 pair, which eliminates 2 and 4 in the rest of the box. So this is 6, which makes that 4. No 4 here. Okay. So this is 2, which makes that odd. This is a 2x2 area that has 3 odds, so this must be even, which makes this odd. Since we have 4 evens here, that means the remaining digit here is odd, which forces this to be even, which means we have 4 evens in row 4, so this must be all odd. That forces this to be even, so this is 6 evens here, which makes this 8, so this can't be 8 here, which makes that 8, so this is 4 or 6. This must be even to not, because we have 5 odds in box 5. This is either 4 or 2 in size, because it can only get 1 more here. This is 2, 4, or 6. 2, 4, or 6. We have 4 evens in column 9, so the rest are odd in that column. Can this ever be 2 then? If we try to have 2 going this way, that would force this to be odd, 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 which is 6 odds in that box, which is not allowed. If we have even, even, this could be odd, odd, and that would work. But then this would be even, even, and we have too many evens in row 3. So no, that doesn't work. So this has to be 4, which means this does not connect to the rest of the island. So if it connected here, that would have to have 5 on this island, so that's not allowed. So this is odd, which means this is even. It must connect to here for the island. We have 5 odds in column 7, so this is even, which forces this to be odd. We have 4 evens in row 2, so this is odd, which forces this to be even. Okay, and then are the reds, do we have no 2x2 area of all reds? So we have green here, 3 greens here, 3 greens here, green here, 2 greens here, 3 greens here, 1, 2, 3, 2, 1, 1, 1, 1, 3, 4, 3, 2, 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 2, 3, 3, 1, 1, 1, 2, 2, 3, 2, 2, 3, 2, 1, 1, 2, 2, 1, 1, 1, 1, 1, 1, 2, 1, 2, 4, 2, 1, 2, 4, 2, 1, 2, 1. So there's no 2 by 2 area that does not have an even digit. So odd sweeper circles, we have 3. We have 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6, 7. This is 5. This is 5, and that works. Islands. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. 8 again. 2, 2, 4, and 6. So now we just have to do normal Sudoku. So this can't be 4, 6, or 8. It's 2, which makes this not 2, so it's 4 and 2. That leaves this as 8, so that's 6. 8 eliminates 8 here, so it's 2, which makes this 4, which makes that 2, which makes that 6, so that's 4 here. This must be 2 here. This can't be 4, 6, so it's 2, which means this can't be 2. This can't be 2, 4, or 6, so this is 8, which makes this 6, which makes that 8. 6 eliminates 6 here, so it's 4, which makes this 6, which makes that 4, which makes that a 6. Okay. Fives. Where this can't be 5 because of 5 in the row. Where is the 5 in row 9? Cannot be here because 5's in the boxes. Can't be here because 5's in the column, so 5 has to be here. Where is the 5 in column 4? Can't be here because 5 in the box. Can't be here because of 5 in the row, so it has to be here. Where is 5 in row 1? Can't be here because 5 in the box. Can't be here because 5 in the column, so it must be there. And we have... Where is... Where is 5 in row 4? Cannot be here because 5 in the box. Can't be here because 5 in the column, so this must be 5, which makes this not 5, so it's 7 and 5. This must be a 7-9 pair, which eliminates 7-9 in the rest of the row. So it can't be 7-9. This is 1-3-1-3. That leaves this digit as a 9, and this as 1, 3, and 7. This is also 1, 3, and 7, but cannot be 3, so this is 1 or 7. This can't be 3, so it's 1 or 7. We have a 1-7-1-7 pair in column 8, so this can't be 1 or 7. It's 3, which eliminates 3 here, 3 here. Okay. I think that should be all the 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. This 7 eliminates 7 here, so it's 9. Oops. This is 9 and 7. This 9 eliminates 9 here, so it's 3. And this must be a 1-9 pair. Okay. Remaining digits in row 1, 1, 7, 9 cannot be 7 here, so this must be 1, 9. We have a 1, 9 pair in row 1, so this can't be 1. This is 7, which makes this 1, which makes that 9, which makes that 7. 1 eliminates 1 here, so that's 9 and 1. That leaves this digit as 7, this digit as 9. And we have a 1, 3 pair here. This 7 eliminates 7 here, so it's 1 and 7. That leaves this digit as a 3. Remaining digits in column 9 are 1 and 9. Where this is also 1 and 9 because of the remaining digits in row 3, but it cannot be 9 because of the 9 in the column. So this is 1, which makes this 9, which makes that 1, which makes this 9, which makes that 1, which makes that 9. This 1 eliminates 1 here, so it's 3, 1, 3, and 1. That leaves this digit as 3 and this digit as 7. Yeah. I don't know. I guess I'm just not... I don't... This was challenging for me. I don't know if it's just something with... I don't know. Maybe my brain's just not quite awake right now. or something. I don't know. It just wasn't. I wasn't functioning very well. Yeah, once I started really thinking about the Nurikabe and then how the islands had to be, that was really what led it to me. But I think this was challenging for me. I'm gonna put this as challenging for myself when I rate the difficulty. But maybe it was easy for you guys. Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.